Okay, just looking at the proofs for cos 3 theta and cos sine theta. So if we look at cos 3 theta, if we treat it as cos 2 theta plus theta, and then we use the cos A plus B rule. So the cos A plus B rule will go cos A, cos B, cos, because you think CC. Cos will be a different sign. Sine will be the same sign. This is cos, so it's a different sign. So it's sine A, sine B. Okay, so let's extend that now and just expand this one. So the A is 2 theta and the B is the same as theta. So it's going to be cos 2 theta, cos theta, that's cos, minus sine 2 theta, sine theta. Now, if you look at what we're trying to do, is trying to get it all in terms of cos. So the part that has the 2 theta, they need to go. So then we need to use our 2 theta rules. So our 2 theta rules, cos 2 theta is cos, which is cos squared, minus sine, which is sine squared, and sine 2 theta, which is 2 sine theta, cos theta. Okay, so let's just take the cos 2 theta and replace it with cos squared minus sine squared, and then take the sine 2 theta and replace that with 2 sine theta, cos theta. Okay, so cos 2 theta would be cos squared theta minus sine squared theta, and because there's two terms you'll need brackets. Then cos theta minus the sine 2 theta is 2 sine theta, cos theta, and then this sine theta here. So that cos theta matches that cos theta, and then sine theta at the end there would be the same sine theta. So just to make that really clear, that's that cos theta, and this is this sine theta, and all that we've done is we've taken the cos 2 theta and replaced it with cos squared minus sine squared, and the sine 2 theta and replaced it with 2 sine theta, cos theta. So continuing on with that, if you expand the bracket here, you might want to write it the other way around if it makes it easier. So it's cos times cos squared minus sine squared, and you can do that because that's a times, and the order your times in doesn't matter. This here we have sine, this is all times, so we'll just multiply sine times sine, so you have 2 sine squared theta, cos theta. Okay, so expanding the brackets here, so cos times cos squared and cos times sine squared. So cos times cos squared is cos cubed minus cos theta, sine squared theta, minus 2 sine squared theta, cos theta. Okay, now there are actually some like terms though if you look. We have cos sine squared and sine squared cos. So if we then collect like terms, so we have cos cubed minus cos theta, sine squared theta. Now if you just have a quick look at what we're trying to get this to, you can see it's all in terms of cos. So the only thing that we have to get rid of now is that sine squared there. So now we go to our 2 unit identities, the one that was cos squared plus sine squared equals 1, and we rearrange it so we have sine squared theta equals 1 minus cos squared theta. Okay, and we replace our sine theta with with 1 minus cos squared. So looking at that, then you have cos squared cubed theta minus cos theta, and the sine squared is 1 minus cos squared theta. Expanding these brackets, you get cos cubed theta minus, there was a 2 here. There's a 2, I've left that 2 out, just a minute. So that's the 2 there, and the 2 should carry through. Okay, so that's 2 cos theta. Just wait a minute there, I'm just fixing this 2 up, because that one there should actually be a 3. Let's just fix that up. So we've got 2 sine squared cos, and we've got 1 cos sine squared, so that's 3 cos sine squared. And that's that sine squared then, so that's a 3 there, goes to 1 minus cos squared. So expanding the brackets now, so you get, that'll be 3 times 1 is 3 cos theta, and 3 times cos squared. 3 cos theta times cos squared gives you plus 3 cos cubed theta. And then if you collect like terms, that would be 4 cos cubed, because you have cos cubed plus 3 cos cubed minus 3 cos theta. Hopefully that makes sense. Okay, now for the sine one. So it's sine 2 theta plus theta. Use the sine rule to expand that. So sine A plus B is sine A cos B plus sine B cos A. Okay, so this is going to be sine 2 theta cos theta plus sine theta cos 2 theta. Because remember, sine is SC. SC for school, so it's sine cos. Okay, so now if you take the sine 2 theta and you change it using the 2 theta rules, so that's going to be, so it's going to be 2 sine theta cos theta, and then times this cos theta, that's that one there, plus sine theta, that's that one, and then we take the cos 2 theta and we change it to cos cos, sine sine, so it's cos squared minus sine squared. So it's 2 sine theta cos squared theta plus sine theta cos squared theta minus sine cube theta when we expand that bracket. So the like terms, we have 3 sine theta cos squared theta minus sine cube theta. And then we take the cos squared and use the identity. So it's sine theta, 3 sine theta, that will be 1 minus sine theta with a square, minus sine cube theta. And then that would be 3 sine theta minus 3 sine cube theta minus sine cube theta. And then if you collect the like terms on that, 3 sine cubed minus sine cubed will give you 3 sine theta minus 4 sine cubed theta. Proven. So that proves that.